So I'm Xavier Ouvrard. I'm working at EcoCloud, which is a research center from EPFL. And we are working on sustainability for IT and AI in particular. So as was mentioned just before, AI can have a great impact on sustainable development goals. This is a publication from Nature 2020 from Nordic country universities. And typically in these publications, they show that on 150 publications, they put a review that it can have positive impacts and also negative impacts. Particularly, the impacts could be on no poverty, on quality education, so the positive ones, on sanitization and clean water, and also on the kind of energy. This is for the society. And negative impacts, I would insist a bit on, it's all on climate change and the consumption of energy of IT. Some examples of AI for good, for instance, are the real-time analysis of risk and the different impacts they can have. Measuring the environmental footprints, particularly the emission in greenhouse gas like methane or carbon dioxide. Biodiversity, tailoring the usage of water for irrigation. And this is important because in some area of the globe, you can also foresee the crops, but if the algorithms have been learned in Western country, then they might not apply in other areas of the world. So this is AI for good, but every time the usage has to be leverage to have the proper usage. Then in reducing ICT emissions, we should think on the smart usage of electricity, particularly of renewable. I will come back with a project we have at EcoCloud, and particularly balancing the workloads and having a better planification and resource allocation depending on the quantity of renewable that you could have. And of course, after you have plenty of things on protection of disinformation, reducing cyber threats. This is AI for good, but also it can be AI for bad, as it is used for these kind of things also. The problem of AI is mostly that the quantity of computation that has to be done for learning the models is increasing a lot, with always more computational power that is behind. This is due particularly to the fact that the hardware is much cheaper than it used to be, and it has increased in performance. And by the same time, this is the worldwide electricity production with different kind of energy. And particularly, we see that even if the renewable are more in the panel of energy that we have, they come, in fact, in addition to the existing energies. IT is consuming more or less 3 to 4% of the worldwide electricity produced in 2020, and it starts to increase, and it's foreseen to be around 7% in 2030. The problem is that electricity and heat represent approximately 32% of the greenhouse gas emissions. And so IT can be a part of the solution, but also part of the problem. So we need to enhance IT of sustainability and AI sustainability to continue to work with it without damaging too much the Earth. So IT relies on infrastructure at different levels, from cloud to terminal via the edge computing. And they are all interlinked with networks that has a cost in transmission of data. So cloud computing typically is done in big data centers that are warehouses, and you have big cupboards this way, and the thing is that you are giving some energy, and the energy is retrieved in the form of heat. This heat can be dispersed either by air or by liquid. Liquid being much more effective, and this can be done at a different level, from the rack level to the server level, and even at the processor level. The fact of going to liquid, in fact, is important because the heat transfer between is 4,000 times better than air. Sustainability is needed at all levels in IT, and sustainability is also needed at every layer of the system. So we can think to reorganize the things so that we have the computation that is done more efficiently, and that the data are not transmitted automatically to the data centers, but are remaining at the terminal layer, and to balance the usage of data calculation at the terminal layer more than on the cloud layer, depending on the renewable that are available. So this is typically the case for experimenting, having a new experimental facility integrated in the data center of close by the data center of EPFL, using some water cooling for the racks, and we will make some experiments on water cooling. And I will just talk about that very quickly. So this is one main project that we have in this experimental area, which is heating bits. And there we want to work on different parts with an holistic approach, from micro-cooling of the servers, tuning the workload depending on the quantity of renewable, providing direct current to the servers, and depending on the season, then we can either inject the heat into the central heating, or regenerating some electricity for dedicated Rankine cycle. I think mostly it's